Okay, so this is going to be a quick review video similar to the stuff we learned Thursday at the end of the period, and it's dealing with shifting and scaling for expected values. Remember that your mean, and I don't have my stylus and nice little notepad, so this is going to be a little different notes, but remember your mean, it just does what's told, does what it is told. So that means if you're supposed to add, it'll add. If you're supposed to subtract, it'll subtract. It will times, and it would even divide if there's dividing problems. Okay, so mean does everything. It's the standard deviation that is the picky one. It does not add or subtract. It will multiply, it will divide, and then when we add multiple sets, there's an extra step. And so I wanted to just have some examples. Okay, so for this one, my original mean is 8, and it's telling me just to do 4 times that, so it's just 4 times 8, and so my expected new mean is 32. This would be a situation if I'm gonna, let's say everything originally cost $8, but now I'm going to quadruple it and make it 4 times as much. So standard deviation also does multiplying, so I will just do 4 times 3, and so the new standard deviation is $12. All right, what happens here is if the original cost of everything was $8 and now it's asking me to increase, let's change this to 9. So then I would just do my original mean plus 9, and so now everything costs $17. Standard deviation does not add or subtract, so it stays the same. So it is still just 3. Okay, here I am doubling the price of everything, but then I'm subtracting $3 from that. So I'm going to double my mean and then subtract 3. And so it's 16 minus 3, and so my expected mean is $13. For standard deviation, again, standard deviation does the multiplying, so I would do 2 times 3, but I will not subtract 3. So it's just going to be, the new standard deviation is going to be 6. All right, down here, when it says x1 plus x2, it's like I bought one thing for $8 and then I'm doing another one for $8. And so it makes a difference when we do standard deviation. Even though it looks like it's 2x, they're different situations, so you have to keep them separate. So you actually do just 8 plus 8, which is 16. But on the standard deviation side, insert an equation. It's a little different. So I'm going to take the square root, and I'm going to take the standard deviation of x, which is 3, and I'm going to square it, and then I'm going to add it to the standard deviation of the second x, which is also 3, and square it. So you square the standard deviations and add them, and you take the square root. And so it is the square root of 18, which is 4.24. Okay. All right, here, again, mean is nice because it just does what it tells you to do. And so the mean of x is 8. So it's 8 minus 3 times the second mean of x, which is still 8. So it's 8 minus 24. So it's negative 16. Here, you have to think about it separately. One thing that's important is that whenever you're subtracting variances, which is what we did here, even if it's a subtraction, it's always a plus here. So I'm going to so I have to take the first standard deviation of x, which is 3, and then I have to, for the next one, this next one, if you notice, it's times 3. And I'm going to actually change it to times 2 right now real quick, just so that it makes more sense. So it's going to be 2 times my standard deviation of x, which is 3, squared. And so, and again, I changed it to 2, so that way when I did the multiplying here, it makes sense. Oops, I didn't want to do that there. And so now I get the square root of 9 plus 2 times 3 is 6, and 6 squared is 36. And so it becomes the square root of 45. I don't have my calculator. So it's about 6.7. Hold up, let me get my calculator. Yeah, so it's 6.71. Okay? All right, so use this. This will help you when you're doing your online assignment, which is the last 10 problems, which is why you're watching the video now. We will practice this some more Wednesday, but Wednesday we're probably also going to have to start going on to something new.